This lesson is on function notation. Function notation is basically, the purpose of this lesson is to show ways in which we can summarize functions and use them to solve or answer questions. In a previous video, I talked about how a function is kind of like a machine. I think in just the general functions lesson, I gave you an analogy that a function is like a working Coke machine. But really, any working machine is a good model of a function. So this is what I'm drawing for you. And this is just a kind of a casual, fun example. So here's a machine, and we'll call it our function machine. In this machine, we're going to place what we call the input, and it's going to travel through the machine, and then once it goes through the function machine, we will get an output. The input of a function is our x value, or our domain. The x is what gets placed into the function, or the function rule, and then it gets processed by the function, and once it's done processing, we get the output. And the symbol for the output looks like this. It's an F, and then parentheses, and then the letter X. F of X is our output. So let me show you again. For function notation, the output is F of X, and that's how it's read. F of X equals X, or whatever the output is. The letter F is actually interchangeable. You'll probably see the letter F most often because F stands for function, but we can use any letter we want to, like G of X, H of X, C of X. But whenever you see F of X, just know that that's the output of the function. So we might be thinking, okay, well, what does that mean exactly? Let's look at a function. Here we have a function that says F of X equals X plus 3. And then we have some evaluation questions. So the first question says, evaluate F of 1. F of 1 equals something. All you have to do is just a little bit of algebra. Wherever you see X in the function, we're going to replace that X with a 1. So in this case, F of 1 will equal 1 plus 3. So F of 1 equals 4. And you know what? I'm just going to make a little table over here to organize some of these. If we have X, here's F of X. So when X was 1, F of X was 4. Okay, let's try again. Evaluate F of negative 5. So we're just going to substitute negative 5 wherever we see X. So that's going to be negative 5 plus 3, which equals negative 2. So F of negative 5 equals negative 2. And again, just because I want to show a table of values, I'm showing a table of values. You don't have to make a table of values unless I ask you to, but I like summarizing these values. Okay, one more. F of 0. So when X is 0, what does F of X equal? So we'll replace 0 with, whenever we see X, 0 plus 3 is 3. So F of 0 equals 3. Whenever X is 0, F of X is 3. Just a little insider tip, or just maybe to kind of make things a little more clear to you. You may have seen equations like this. Y equals X plus 3. And you may have seen this kind of T-chart where you looked at X and Y, this is the exact same thing. The only difference is that instead of using the value y to represent the output, we're just using f of x. And once you get more comfortable using the terminology f of x, I find that it actually summarizes these relationships better than just saying y. Okay, let's try another one. F of x equals negative x plus 1. I want you to try these. Press pause and evaluate f of 2, f of 100, and f of negative 1. When you're ready to check your answers, press play and see how you did. All right, hopefully you evaluated these and you got these answers. F of 2 equals negative 1. F of 100 equals negative 99. And f of negative 1 equals 2. If you need to see a little further explanation of why f of 2 equals negative 1 or f of 100 equals negative 99, then keep watching and I'll show you the worked out version. If you got these, then move on to the next example. So f of 2, we are going to replace wherever we see x with a 2. So that's going to be negative 2. Keep that negative. Plus 1. Then we can evaluate. Negative 2 plus 1 equals negative 1. For the next one, negative, then I replace x with 100. Negative 100 plus 1 equals negative 99. And then lastly, f of negative 1. So that's going to be negative 1 plus 1. Well, negative 1, whenever you do a negative times a negative, you get a positive. So really this problem is 1 plus 1. So f of negative 1 equals 2. All right, next function. G of x equals x squared. Remember, you can replace the letter f with any letter you want to. So this one's a G just because. G of 0. Since this is x squared, I'm going to do 0 squared, and 0 times 0 is 0. F of negative 4. That's going to be negative 4 squared. Negative 4 times negative 4 is positive 16. Be on the lookout. If you're using your calculator and you want to square the value negative 4, you have to use parentheses. Negative 4 times negative 4, or negative 4 squared is positive 16. If you put this into your calculator, negative 4 squared without the parentheses, your calculator is going to square the 4 first and then apply the negative. This is a very common mistake that I see people make with calculators that's completely avoidable. So remember, whenever you're trying to square the actual negative number, use parentheses. Okay, last one, G of 11. So that would be 11 squared, and 11 squared is 121. Okay, you try. Press pause. I want you to evaluate these examples. H of 3 is negative 8. H of negative 2 is negative 3. H of negative 5 is negative 24. If these are the values that you got, congratulations, you can move on. If you didn't get these, stick around and watch how I evaluate them. So H of negative 3, I'm going to take H of 3, I'm going to take x and replace it with a 3. So that'll make it negative 3 squared plus 1. Notice how I keep the parentheses around the 3. Whenever you're substituting a value, it's a good idea to leave it in parentheses. So this becomes negative 3 squared is positive 9, or I don't know why I keep saying negative 3. Positive 3 squared is positive 9, but then we're going to apply a negative to it. So really this is negative 9 plus 1, which is negative 8. Okay, the next one, negative 2 squared plus 1. So when we square negative 2, we get positive 4. But since this whole thing was supposed to be negative, it's negative 4 plus 1, which is negative 3. The last example, h of negative 5, so that would be negative 5 squared plus 1, which is going to be negative 25 plus 1, and you'll get negative 24. This is how you can use function notation to evaluate actual values within the function. Sometimes you'll get values and you'll have to try and figure out what the rule is. So for example, here I have x values that are related to f of x values. Look at these examples. See if you can figure out what is being done every time to x in order to get f of x. Usually when I look at these, I try and see if the same number is being added to every x value or subtracted, or I try to see if every x value is being multiplied by the same number. So in this case, if you notice, like we have negative 1, negative 4, 1, positive 4. We're actually multiplying all of these values by 4. 0 times 4 is 0. Okay, so since we are multiplying every x value by 4, then f of x equals 4 times x. Now that we know what the rule is, if I asked you a question like, what is f of 30, you can very easily substitute 30 into the function rule and tell me that f of 30 is 4 times 30, which is 120. 30 was just an arbitrary example. But now that we know the rule, we could find out any x value and y value combination, or f of x value. You try it. This one's a little trickier. See if you can find the function rule. Look at every x value and f of x value. One thing I notice, or that it's good to notice, is the 0 value. 0 to 1, so we had to add 1 at some point. If I added 1 to get 7, that would mean like 6 plus 1 would equal 7. 4 plus 1 would equal 5. 2 plus 1, remember 0 plus 1 gets us 1. Negative 2 plus 1 will get us negative 1. And then negative 4 plus 1 will get us negative 3. This is kind of a trial and error process. But now I can compare all of these values. And to get to each of these, it looks like you're multiplying by negative 2. 0 times negative 2 is 0. Looks like we multiply 1 by negative 2. Okay, so our function rule, each of these x values got multiplied by -2, and then we added 1 to every one to get our final f of x. So this particular function rule is -2x plus 1. That was kind of a challenging one. If you got that one, congratulations. All right, my next example, it actually is a word problem. We can use functions to describe relationships in real life. And this is where I like using the different letters to represent different values. Here's the example. All cell phone company charges their customers a monthly fee of $7 plus 10 cents per minute they're talking on the phone. Oh, I think I have a typo there. Or every minute they spend talking on their phone. This relationship can be modeled with a function C of m equals 7 plus 0.1 m, where m represents minutes used and C of m represents the cell phone bill amount for the month. Find C of 200. So basically this is saying, what is the cost of that person's cell phone bill if they spent 200 minutes that month on the phone? So we're going to take 200 and plug it in for m. So C of 200 equals $7 plus 10 cents times the 200 minutes they spent talking. So this equals a total of $27 for the month. Obviously this person doesn't spend much time talking on the phone, or they do a lot of text messaging and they have free text messaging. I don't know. I would like a $27 a month cell phone bill. All right, moving on. Complete the table. Remember, m is minutes spent talking, and C of m is cost. Okay. Try and evaluate this yourself. Press pause, see if you can complete the table. Once you plug in 50 minutes, 100 minutes, and 130 minutes, you should get the following totals. $12, $17, and $20. The last two ones, we have the total cost. We just need to figure out how many minutes gave us that total cost. Well, $27, that's the previous example. If you go back up to A, you should see that that was 200 minutes. If you multiply 200 by 10 cents and then you add 7, that'll give you $27. So this is 200. $57, we need to do a little extra work. $7 plus 10 cents for m minutes equals 57. So to solve this, I'm going to subtract 7, and that'll give me 10 cents a minute for m minutes should be a total of 50. So then divide. M equals 500 minutes. There you go. This is a really good example of how we can apply function rules to evaluate some real life problems. The cell phone bill that you receive or your parents receive in the mail isn't just some arbitrary values that they decide to assign to you. There's probably a formula that your cell phone company actually uses to charge your family their cell phone bill. They probably look at amount of minutes, and then you may have some flat fees in there as well. So one interesting thing to do would be maybe to ask your parents if you could see the cell phone bill and see if you can figure out what formula they're using to calculate it. All right, we have a couple more examples. And look at this title. It says, functions can be graphs too. Remember, a graph is a visual representation of a whole lot of points. Every single point on here has an x and y value. So for example, this point here that I've highlighted, the coordinates of this point are 2, 0. So the x value is 2, and then the f of x value at that instance is 0. So look at the problems. Find f of -1. All it's asking you to do is read the graph. When x is -1, what does y equal? Well, let's look. That would be 1, 2, 3, so -3. The coordinates of that point are -1, -3. Okay, let's try another one. What is f of +3? So let's count over 1, 2, 3, and then go up the graph. 1, 2, 3, 4, 5. The coordinates of this point are 3, 5. So f of 3 is 5. Last one. Find f of 0. 0 is right here on that y-axis, and we'll move down 1, 2, 3, 4. Okay, f of 0 is -4. Okay, one more example. What value or values of x makes f of x equal 5? So this time I have given you the output or the y value, and you have to find out what x values have a y value of 5. So we already saw one, which was here. It has a y value of 5. So I can already answer that 3 does. But go back and look at the graph. There's this other point over here. It has an x or a y value of 5 as well. -3, 5 is another combination where the output is 5. So I'm going to say 3 and -5. Those are two x values that have y values or output values of 5. Okay, you try this on your own. Press pause, see if you can answer these 4 questions, and when you're ready to check your work, press play. Okay, first question, find f of -1. So according to this graph, here's -1, and this goes up 1, 2, 3, 4, 5, 6. So f of -1 is 6. Find f of 2.5, so about 2.5. Well, we kind of have to approximate. Got something weird going on with my computer. Okay, 2.5. Looks like it's about up here. I'm going to estimate that 2.5 is around here. So f of 2.5 is approximately 1, 2, 3, 4, 5, 6, 7, 8. It's an approximation. It's okay if it's not the exact value, but if it's pretty close, that's good enough. Okay, last one, f of 0. Well, that would be here at what we call the origin. So it looks like f of 0 is 0. What value or values of x make f of x equal 4? So I'm going to look at the y value 4. Actually, let's use a highlighter and see if we can identify which x values have y values of 4. It looks like here. Okay, we're going to have to approximate. So I'm going to say that this is about -2 3/4. Looks like for here, this one, same thing. It's about -3/4. And then the last one, that one looks like it's about, if I were to guess, I would say that this is about 2 1/4. Okay, that sums it up. Just remember function notation. F of x is just showing a relationship between input and output. And anything inside those parentheses is what the actual input is.